Today's lecture we're going to go over our textbook chapter 1.1, Positive and Negative Numbers. You may remember our number line. So before we started with 0 and we counted 1, 2, 3, 4 and so on, and we only worried about our right hand direction. Now we're going to call those our positive direction and our positive number. And in the opposite direction, we have -1, -2, -3, -4, -5, and so on. If we move to the left, that is going to be our negative direction, and it's going to take care of our negative numbers. Right in the middle, we have 0. That is our origin. 0 technically is not positive, nor is it negative. It's our origin. Sometimes people put it into positive numbers, but really it doesn't have a sign. It's just our starting point, our origin. When we move to the left, our numbers get smaller. When we move to the right, numbers get larger. Now it may make sense from 0 on. As we move to the right, our numbers get larger. 1, 2 is larger than 1, 3 is larger than 2, and so on. Now in our negative direction, even though we work from -1 to -2 to -3, we're still moving in the left direction, and therefore our numbers get smaller and smaller and smaller. So it might be counterintuitive, but -5 is smaller than -3. Now when we talk about numbers that are smaller and bigger, we're actually comparing numbers, and we have some notation for comparing numbers. We say if A and B are any two numbers on the number line, then A, with this little arrow, B is read A is less than B. A, with the arrow pointing in the opposite direction, B, is read A is greater than B. Now here's the trick of the arrows. Wherever the pointy end is pointing, that's the smaller number. So A is less than B. A would be smaller than B. A is greater than B. You see the pointy end is pointing to the B, so the B is going to be the smaller number. And A is the bigger number, so A is greater than B. So for example, 3, with the arrow pointing towards the 3 is less than 5. It's also correct to say that 5 is greater than 3. Both of these statements are correct. We say the statements are true. So statements are either true or false, and when it is correct, we call it true. 0 is greater than 100. No, that's not correct, so it's a false statement. 0 is not greater than 100. So next, let's try one with negative numbers. -3 is less than 5. Yes, that's true. -3 is to the left of 5, and if you remember, up on the number line, 5 is way over here to the right, and -3 is to its left, so it is a smaller number. So it is less than 5. -5 is less than -2. That is true, because remember, -5 is still to the left of 2 if you wrote it out on a number line. Now we have some terminology. It's called absolute value. So here's our vocabulary, absolute value. Absolute value is just the distance from the number from 0, the origin. So let me go back to the number line up here. The absolute value of 1 is 1. It's 1 unit away from 0. The absolute value of 2 is 2. It is 2 away from 0. Now let's try it in the other direction. The absolute value of -1 is 1 because it's 1 unit away from 0. Let's try negative 2. Negative 2, the absolute value of negative 2, is 2 because it is 2 units away from 0. Now we have the notation of absolute value as 2 vertical bars. So the absolute value, these 2 vertical bars, negative 3, is 3 because on a number line, negative 3 is 3 away from 0. Now let's try a few examples. So absolute value of 5, absolute value of negative 3, and absolute value of 7. Well, the absolute value of 5 is 5 because 5 is 5 away from 0. The absolute value of 3 is 3 because remember on the number line, negative 3 is 3 away from 0. And negative 7, the absolute value of negative 7, is 7 because it is 7 away from 0. Now another bit of terminology or vocabulary is opposites. So if two numbers that are in the same distance from 0 but in the opposite direction, those are opposites. So for a generic form, the opposite of A is negative A. So let's think about what is the opposite of 5. So 5 is in the right-hand direction. So what's in the left-hand direction? Negative 5. What's the opposite of 7? Well, if 7 is to the right, we need to go to the left the same distance. So that's negative 7. The opposite of 1? Negative 1. The opposite of negative 5? Now we're over on the left. Let's go to the right 5 spots. It is positive 5. And we could write positive 5 as plus 5, but when it's just with the number, we tend to leave off the plus for positive. And the last one, the opposite of negative 8, is positive 8. I'm just going to put those down just for emphasis, the positive signs. All right, so here's a property that we have in mathematics. If A represents any positive number, then it is always true that the opposite of negative A is A. So that's how we read it. This first minus sign or negative sign means the opposite, and then the one that is in the parentheses is negative A. So the opposite of negative A is A. Let's go through each of these examples, and each of the signs, either the plus or minus, are read a certain way, and it indicates certain things. So 3 plus 5, the plus sign in this case indicates that it's addition. Plus 4 or positive 4, the plus sign is read positive 4, meaning not negative 4, but to the right of 0 4 units. So positive 4. 7 minus 2, the minus sign in this case indicates subtraction, whereas minus 7 indicates negative 7. And minus 5 or //5, however you want to read it, it's actually read the opposite of negative 5. And the opposite of negative 5 is positive 5. So now let's talk about a little bit more about numbers. And we have a group of numbers. And if you remember, we chatted about whole numbers, which were the counting numbers 1, 2, 3, 4, as well as 0. So the whole numbers are 0, 1, 2, 3, and so on. Now that we have the negatives of numbers, if we put all of those numbers together, the positives and the negatives as well as 0, we have the integers. It's just a special name for all whole numbers, both negative and positive, including 0. Let's switch gears a little bit and talk about scatter diagrams as well as line charts. Scatter diagrams are just taking data information and we plotted on a scale. Now we had some diagrams of bar charts. Now let's talk about scatter diagrams. So I'm going to show you some data, and this is Alaska monthly temperatures. So in January it's minus 50 degrees, February minus 44, March minus 32, and so on all throughout the year, ending in December as negative 49. Now we can put it on a scatter diagram, and what we're going to do is on the bottom of our chart we're going to write down the months, January, February, March, April, all the way through December, and then vertically we've added or we've labeled temperatures all the way from negative 60 all the way to positive 30, but we didn't list every single one. We didn't say negative 50, negative 49, negative 48, and so on. We just did it by tens. And let's go ahead and plot. So January is negative 50. So January, we're just going to put a dot at negative 50. February, well, we don't have a 44, so we're going to guesstimate where a 44 is. It's not quite halfway through it there, between 50 and 40, negative 40 and negative 50. March, negative 32, May, negative 5, and so on. So for each month, we're going to plot where they land on our scale. So July was way up at 19. July was all the way at 24. August at 18. September at 8. October is 2. November is negative 27. And December is negative 49. This is a scatter diagram. So we're only plotting each point. Now if we connect each of the dots, same plot, same dots, but if we connect them, it's now a line chart. That's just two ways of showing data, the same data, but in different diagram types. So one is the scatter diagram, and the other is a line chart. So that's it for this lesson. So until later, be seeing you.